tougher here. Let's see, the x squared takes care of the left and the right, but this term, no, this is always positive, right?
I believe so.
Well, I mean, if you plug in anything other than 0, it's always positive. In other words, if I plug in minus 0.01, let's do that. We got minus 1 divided by minus 0.01, that's approaching it from the left, times 0.99. Well, that looks like it goes to positive infinity. In other words, the negative signs cancel.
Got it.
Hold on. No, I didn't do that right. I didn't do that right. They don't cancel. It goes to negative infinity. If I approach 0 from the left, which a number that I might put in would be negative 0.01, right?
Yeah.
But when I square it, turns this positive. This is always positive. So my denominator is always positive. So this is going to go to negative infinity. Now let's approach it from the right. Well, I might put in 0, 1. Square that. This is 1.01. Well, that also goes to negative infinity. Therefore, the limit does exist, and it's negative infinity.
Yeah.
All right, let's have a look at 45. Interesting, so far, all the ones we've done, if it goes to a number without going from the left to the right, it exists, right? In other words, they haven't given us one yet that does not exist. 45 is what?
So infinity.
Okay, 45b.
Negative infinity.
Yeah, because when you take the cube root of a negative number, it stays negative.
Yeah, because it's a cubed root. Okay.
Right, because it's cube root. If that was square root, then I wouldn't be able to approach it from the left.
Got it.
Because you can't take the square root of negative numbers. So only cube roots, but it's worth remembering that when you take the cube root of a negative number, you get a negative answer. In other words, the cube root of negative 8 is negative 2. The cube root of positive 8 is positive 2. It's not like square roots where you get a plus and a minus. How about 46?
Infinity.
46b.
Then would it be negative infinity because it's in the fifth?
Because it's an odd root, exactly.
Okay.
In other words, whenever you take an odd root, whether it's cube, a fifth, a seventh, a ninth, doesn't change the sign.
Okay.
47.
Would that be infinity?
Yeah, notice that as we approach from the right, the bottom is positive. But even as we approach from the left, we've got the fifth root of a negative number, which is negative, but then we square it, so it becomes positive. So from the left and the right, the denominator is positive. So that is positive infinity. 48.
I think that'd be infinity.
Also, same exact as 47. If we're
yeah.
In other words, if x is negative, the cube root is negative, but then we square it, it turns positive, just like 47.
Okay.
So it doesn't matter whether x is positive or negative, we're going to get a positive number.
Got it.
Although there's a lot of math behind the explanation to that also. I think I showed you this once. Just for your information. What do you think that answer is?
2 or -2.
Well, the cube root of -8 is -2, but then we square it, so it looks like it should be 4, right?
Correct.
Well, if you put that into Wolfram alpha, you don't get 4. You get an imaginary number. And the explanation for that is really, really high-level math, way beyond the scope. I'm not even sure I can explain it, but it has to do with nth roots. But technically, that is not 4. And you can prove it by just putting it into Wolfram alpha. Put -8 raised to the 2/3 power, and it'll show you what the answer is. I think it's an imaginary number. They give you nothing but a complex answer that is not 4, or any way, shape, or means 4. So some of these get a little tricky the way they're talking about it. 49 next?
Yes.
Well, perhaps the best thing to do on 49 is to draw the tangent curve. We know it goes between -pi/2 and pi/2. And it looks like this. Okay? So they're asking, what is the limit as we approach pi/2 from the left?
Infinity? Or no, -infinity.
Oh, you had it right.
Okay.
In other words, there's a vertical asymptote every pi. So the curve repeats like that. So just read it from the curve. If I'm approaching this point from the left, excuse me, you're right the first place, positive infinity. I don't know if that's what you said.
No, I did say positive, but then I said yeah after.
Well, positive infinity is correct if you look at the curve, the graph, right? In other words, as I'm approaching from this direction, I'm way up here. What is it as I approach it from the right? Number 50. Hold on. Let's talk about tangent x first. What would it be?
Okay.
What would it be if I approached from the right?
Infinity, it looks like.
Well, I'm sorry. I kind of screwed this up. First of all, we're approaching pi/2, not -pi/2. Let's see if it matters. Let's see. As I approach from the left, I'm up here at positive infinity. If I were to approach it from the right, I'd be down here at negative infinity. So the answer to 49 is definitely positive infinity. Okay?
Okay.
Secant. Secant is the reciprocal of what? Sine or cosine?
Cosine.
Okay, so if I draw the cosine, I don't know why, just in my brain, I almost have to draw the cosine, and then I put the secant on the tops and the bottoms of the cosine curve. And there's a vertical asymptote. Everywhere where the cosine is 0, there's going to be a vertical asymptote. Because notice that secant is the reciprocal, so if cosine is 0, then you're going to be dividing by 0. Okay? And we're approaching -pi/2, which is right there, from the right. What's 50?
So negative 2 from the right. It looks like,
Here, let me erase the cosine curve. It's just
okay,
using the issue. Now approach negative pi over 2
from the right.
I'm approaching it from the right.
It looks like it's coming from infinity.
Well, I'm looking up here, right?
Yes.
In other words, when you approach something, you're always looking on the horizontal axis. But when you want to know what its limit is, you look to the vertical axis.
Yes.
Okay, well, I'm approaching from the right, and as I get closer and closer to minus pi over 2, this thing gets higher and higher and higher.
Whatever that little point is that it meets.
Well, it never meets. In other words, it never touches these vertical asymptotes. It just keeps going up all the way to infinity on both sides. In other words, if I approached pi over 2 from the left, it would also go to positive infinity.
Okay.
But if I approach pi over 2 from the right, I'm down here at negative infinity.
Got it.
Okay. Cosecant. Well, what's the cosecant? The cosecant sits on top of the sine curve. So it is going to look like this. With vertical asymptotes wherever sine is 0. Okay, so that's the cosecant curve. And plus 1, or what's the 1 going to do?
It looks like it's just going to keep going up.
Well, it's a vertical shift, right?
Yes.
In other words, it's outside the function. You can say this is cosecant of theta plus 1, which is the cosecant curve. Everything moved up 1. So
Okay.
cosecant plus 1 goes up to there, and it starts at 2 instead of the normal 1. Doesn't really affect its limits, though, does it? In other words, whenever I just make a vertical move here, I'm not going to affect the limit as I approach 0. There's another one over here. So here's 0. If I approach it from the left, what is it?
It looks like it's at 2.
No?
Or
Approach
not.
from
Or no, 0, 0, 0.
Not 0. Remember, when you approach 0, you approach on the horizontal axis, but you read your answer from the vertical reading. Well, the closer and closer I get to 0, I'm way down here, right?
And negative infinity?
Correct. Always the way to think of limits, especially if you're reading them from graphs, is to hop on board the graph. Well, I'm hopping on board the graph, and I'm going to approach 0. Well, the closer I get to 0, the more negative infinity I get. You see that? Very, very important concept with limits. A lot of people really have trouble with this. You got to approach on the horizontal axis, but you got to read your limit from the vertical axis.
Okay.
Okay? So it only approaches 2 when I'm approaching this point right here, from the left or the right. If I were to approach this point right there from the left or the right, this function approaches 2.
Got it.
Okay, 52. Well, cotangent goes between 0. Here's what the cotangent curve normally looks like. Or this is pi, and that's 0. Excuse me, that's not what it looks like. That's a tangent curve. Cotangent curve is always decreasing like that. This is a negative cotangent. In other words, I could write that as negative cotangent of theta plus 2, right?
Mm-hmm.
Well, the negative sign causes me to flip that. So it really is the way I originally drew it, like this. The green is the negative cotangent curve. And adding 2 to it isn't going to make any difference if our answer is either negative infinity or positive infinity. And it's going to be one of those. So as I approach 0,
It looks like it's going to be going down.
let me first of all draw another. In other words, I didn't draw enough periods of it to show you what it looks like. That's what our function looks like. 2 periods of it. Okay? Now you can go from the left and the right. So if I approach 0 from the left, what does this thing go to? Ignore the plus 2 because it's not going to affect anything. This curve right here is negative cotangent of theta. So as I approach 0 on the horizontal axis from the left, what is my function doing?
It looks like it's moving upwards to infinity.
Correct. Now as I approach it from the right, what is my function doing?
Going to negative infinity.
So what's the answer to 52?
Undefined.
Not undefined, does not exist.
Okay.
And they're different. Does not exist means that limit doesn't exist. Undefined is frequently used in place of infinity. In other words, infinity and undefined are frequently interchanged, but does not exist in undefined. Maybe, I don't know. I suppose there's teachers that are going to interchange those also. I like the terminology. I really don't like undefined, to be honest with you. Does not exist makes a lot of difference to me because that's what you get if it's not the same from the left as it is from the right.
Uh-huh.
And infinity makes a lot of sense to me. But what does undefined mean? I'm not sure. So I don't like using that ever as an answer, but I understand that your teachers might. 53 next.
Yes.
What's A?
Would that be 4 minus 4, 1 over 0? Would that be infinity?
Good. What's B?
B would be negative infinity?
Well,
Or no, that would be infinity because it's squared.
right, exactly. In other words, if I put in a number that approaches 2 from the left, maybe it would be 2.1. Okay? But I'm squaring it. Minus 4, so that's a positive denominator now. And so that is positive infinity. And if I approach it from the right, I'm going to put in 1.9. Now when I square that, that turns positive, but I still have a negative denominator, notice.
Okay.
So when I approach it from the right, it's negative infinity. In other words, it doesn't make the entire denominator positive. It makes this part positive, but if I'm approaching it from the right, this entire denominator is always going to be positive. Excuse me. Negative.
Okay.
Right?
So that would be,
Because this becomes a positive number close to 4, but like 3.9. In other words, you would end up with 1 over a positive 3.9 minus 4. That's a negative denominator, which means that thing goes to negative infinity. So A goes to positive infinity, B goes to negative infinity. Wow, I screwed this one up too. I was doing C and D. Because I was approaching -2 in both cases. Okay, well, let's go back and do A and B. Well, A, you end up with, we're approaching 2 from the right, so this is going to be like 4.1 after I square it. Leaves a positive denominator. That goes to positive infinity. But if I approach 2 from the left, I get this situation, which gives me a negative denominator. And that goes to negative infinity. So in fact, it doesn't really matter. A is the same answer as C, and B is the same answer as D. That's because we're squaring it before we subtract 4. Notice that it would make quite a bit of difference if the problem was this. If the problem was actually 1 over x minus 4 squared, and I'm approaching 4 from the left or right, it wouldn't matter. They're both going to go to positive infinity. But the fact that it's 1 over x squared minus 4, that does matter because I'm not automatically squaring my whatever denominator I get. I'm just squaring the x, and then I'm subtracting 4. So if this comes out to be less than 4, I'm still left with a negative denominator. Taylor, I've got a 7:30 I got to run to, so I'm going to have to leave you.
Okay. Thank you.
You're welcome. Talk to you later. Bye-bye.
Good night.